Now we learn factors. A factor of a given number is a number which divides the given number exactly without leaving any kind of remainder. Thus 5 is a factor of 15. 5 divides 15 exactly and does not leave any remainder. But 10 is not a factor of 15, because when you will divide 15 by 10, it will leave a remainder of 5. So 10 is not a factor of 15. Similarly, 7 is not a factor of 20. When you will divide 20 by 7, there will be a remainder. So a factor of a number is a number which divides the number exactly and does not leave any remainder. Now here one question is given: find all factors of 72. Now you can write 72 as 1 into 72, 2 into 36, 3 into 24, 4 into 18, 6 into 12, 8 into 9. So 72 could be written in these many ways. So this shows that 72 is exactly divisible by 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36 and 72. It is not divisible by other natural numbers like 5, 7, 10, 11, etc. So we can say that these all are the factors of 72, and when 72 is divided by any of these numbers, it will not leave any remainder. Now here one question is there in your exercise: determine whether 39 is a factor of 13,962. You have to determine, you have to find out that whether 39 is a factor of 13,962 or not. So what you will do, you will divide this number by 39, and if it leaves any remainder, that means 39 is not a factor of this number, and if the remainder is 0, if it does not leave any remainder, then it means that 39 is a factor of 13,962. See, here I have divided 13,962 by 39, and the remainder that I am getting is 0. The remainder is 0. That means 39 is a factor of this number. Now the next question is: without actual division, show that 17 is a factor of 17,017. Now you cannot use division method here. Here in this question we used division method. We divided 13,962 by 39, and then we found out that 39 is a factor of this number. Here we cannot use division method. Without division method, we have to show that this 17 is a factor of this number. Let us see how can we do that. See, 17,017 can be written as 17,000 plus 17. Yeah, and then 17,000, I can break this 17,000 as 17 into 1,000. Yeah, and then in these two numbers, what is common? 17 is common. So I'll take 17 common, and then what is left? 1000 here, and as I have taken out 17 as common number, so here I'll write 1. Now 17 into 1000 plus 1 is 1001. So this number could be written as 17 into 1001. So this shows that 17 is a factor of 17,017. Now what are multiples? A multiple of any natural number is a number formed by multiplying that number by any whole number. For example, 6. Multiples of 6 are 0, 6, 12, 18, 24, 30. When I will multiply any whole number by 6, I'll get the multiples of 6. When 6 is multiplied by 0, I'll get the multiple 0. When 6 is multiplied by 2, I'll get the multiple of 6 as 12. When 6 is multiplied by 3, I'll get 6 multiple as 18. So when I am multiplying any whole number by 6, I am getting the multiples of 6. Now let us look at the question. The question says that list the first 5 multiples of 16. So how we'll find out the first 5 multiples of 16? We'll multiply 16 by 1, 2, 3, 4 and 5. So 16 ones are 16, 16 twos are 32, 16 threes are 48, 16 fours are 64 and 16 fives are 80. So these are the first 5 multiples of 16. Now the second question is write the 12th multiple of 75. You have to find out the 12th multiple of 75. So simply you have to multiply 75 by 12 and then you can find out the 12th multiple of 75. Now let us look at even and odd numbers. Now what are even numbers? All natural numbers exactly divisible by 2 or all the multiples of 2 are known as even numbers. For example, 2, 4, 6, 8, 10, these are all even numbers. What are odd numbers? All natural numbers which are not exactly divisible by 2 or are not the multiples of 2 are called odd numbers. For example, 1, 3, 5, 7, 9, 11. You can see that these are not divisible by 2 or these are not the multiples of 2. So these are what? Odd numbers. Now we learn about the prime and composite numbers. What are prime numbers? A prime number is a whole number greater than 1 which is divisible only by itself and 1. Or you can say that a number which has only 2 factors which is divisible only by itself and 1 is called a prime number. A natural number greater than 1 which is not prime is called a composite number. Or you can say that composite numbers are those numbers which have more than 2 factors. So example of prime numbers could be 2, 3, 5, 7. Example of composite numbers would be 4, 6, 8 and 9. These are all composite numbers. Now what are coprimes? Two natural numbers which have only the common factor 1 are called coprimes. A few pairs of coprimes are written here. See, 2, 3. These two numbers have only the common factor 1. Here also 3, 4. These both the numbers are natural numbers and their common factor is only 1. So these are coprimes. 4, 9. They have the only common factor 1. So they are coprimes. Now what are twin primes? Prime numbers that differ by 2 are called twin primes. Here you can see some pairs 3, 5. Both are prime numbers and their difference is what? 2. So they are called twin primes. 11 and 13. Both are prime numbers. Their difference is 2. So they are called twin primes. Now prime triplet. A set of 3 consecutive prime numbers differing by 2 is called a prime triplet. The only prime triplet known so far is 3, 5, 7. Now let us move on to the questions. Here the question says that name 2 primes with product 6. You have to name 2 primes and their product has to be 6. So the 2 primes that I can take here is 2 and 3 and their product is 6. Now 35 can also be written as 7 into 5 and their product is 35 and both the numbers are prime numbers. Now you have to name 2 primes with sum 42. I can take any 2 primes but their sum has to be what? 42. So here I can write 42 as 19 plus 23 or I can write it as 37 plus 5. I have taken 2 prime numbers and their sum is also 42. Now 60, I can write 60 as 29 plus 31. The thing is that you can take any 2 prime numbers but their sum has to be the given number. Now the next question is express as the sum of twin primes. You know that twin primes are prime numbers that differ by 2. So here you have to keep three things in your mind. First thing, that the two numbers has to be prime numbers. Second thing, that they both should differ by 2. And the third thing is that their sum has to be 24. So two prime numbers that I can take here is 11 and 13. Both are prime numbers and they differ by 2 also. Their difference is 2 and their sum is also 24. Now the next question is express as a sum of 3 odd primes. You have to take 3 prime numbers, but you can take only odd primes. You cannot take even primes, and their sum also has to be 31. So here I can take 3, 5, 23. 3 plus 5 plus 23 will give you 31. So as you can see that these three numbers are odd numbers and they are prime numbers also, and their sum is also 31.